Okay, I want to start out today by talking about some upcoming projects. We will be going over the lab exam on Tuesday when you come to lab. And that will also be the start of your unknowns project. But I wanted to go ahead and pass out to you some information about what to be looking at for your unknowns project. This paper, I will go over it on Tuesday. But I thought I would just go ahead and give it to you while I'm giving you a bunch of papers. The info about how your unknowns reports will be. But I want to spend more of the time this morning going over your parasite presentation. So all of you, when you sat down, there's a little folded up piece of paper, and this is your parasite that is assigned to you that you'll develop a presentation about. So if everybody would just go ahead and tell me what parasite you have, give it your best shot at pronunciation, and I'm going to write those down. Constant, what do you have? Gandhi, yep. Brooke.
Trinidad, Lambla?
Giardia. Lamblia.
Yeah.
Sneak a peek at Sam's. Okay. Samantha, yours is Ascaris lumbricoides, and I will email that to you later. Carissa, what do you have?
Histoplasma capsulatum.
Okay. And Hawken, you had Naegleria.
No, fowleri.
Fowleri. Liv, what do you have? Good. That is correct pronunciation. Grady, how about you? Uh-huh. Addie. Yeah, Borrelia burgdorferi. And then Chelsea, what do you have? Rickettsia, yeah. Rickettsia rickettsii. And then Alessa, Trypanosoma cruzi. Okay, so now I've got them all written down. Recorded who has what. So the reason that I assigned this project to you all is two major reasons. One is so that you have an extra test grade that's not a test. Like a project that you can work on as much as you want, make it as good as you want, that becomes an extra grade. There's really three reasons. Second reason is so that you have practice presenting clinical, scientific kind of knowledge before you get into nursing school. And the third is so that we get a quick look at eukaryotes that tend to infect people in this region. And I could do all of that in one day in a lecture, but this lets you all do it and present it to the class and have an extra grade. And I like to see what you present. So these are going to be 3 to 5. Where does this say?
5 to 6.
5 to 6. Thank you. 5 to 6 minutes for you to put together a presentation and give that has this info in it. It's pretty short, but you do need to practice it, and it needs to include this basic info. Those will be happening during lab time on Tuesday the 17th, and probably what I'm going to try to do is get in this room and have all of us meet at one time on that day so that everybody can hear all of them all at once, instead of do the 6 and 4 thing. Like
With the
labs.
so there's a test on the information on.
Yeah, so the way that will work, you'll come up and present about your parasite, these basic facts, and then you also will post on Canvas a little like review sheet thing for your parasite. And I take those and I make matching questions out of them for the exam. So there'll be the list of, this is the name of the organism, and then there's some description over for the matching that like, it causes this disease, or this one causes brain damage, or this one you get it from whatever's the basic info. So it will be, that stuff will show up on the final.
So
I
pretty
think
much
it's
just
the
bullet
final.
pointed then?
Yeah, so your
Just
review
like
sheet
the
should
final.
not be a paragraph, and it should not have every single thing that you put in the slides, but like, what are the basic special things about this parasite? What are the things that make this one different than everything else? So, like a lot of these cause diarrhea. That's not that special, but there's only one of them that infects your brain, and there's two of them that you get from ticks, and one of them has to do with cats. One of them's a STD. Yours. So the thing that's special about yours, like what are the top 5 special things that would go on your review sheet? Tuesday the 10th, so a week ahead of your presentation, you'll need to send me what are the sources that you're using for this. Don't use like Dr. Mercola or naturetherapeutics.com, or these need to be well-respected websites. WebMD or CDC or Mayo Clinic, that kind of high-quality sources. And if you have questions whether a source is high quality, we can talk about those later on as you're looking for it. I've also given you the scoring here. So this is the scoring rubric, and I'll be doing one of these for all of you. Since this is a small class, you're going to do this individually. So it's just you don't have a partner. We'll learn 10 different pathogens, but here's the stuff, and then as you're giving it, I'm just sitting there scoring. Did you get that? So this, half of it's content, and then half of it is how you structure your talk. So you have good sources. You need to have a picture on every page for a short talk like this. So a picture on every slide, and you need to reference where did you get that picture also on the slide. So that's the visuals part. You need to not have typos and spelling errors on your slides in your sheet. And notice out there, that's a ×2 category. Like, that's something I'm real picky about. The slides and the info sheet. It needs to be 5 or 6 minutes. If it's 3 minutes, that's not very good. If it's 10 minutes, that's not very good. And you'll need to practice to see, like, have I got too much, or do I need to add more? Most people don't have enough in the past. People can ask questions after your talk. I will definitely ask you a question. And then this bottom category is like, did you make people care about this? Did you make it interesting? And all of these are actually interesting. They're all pretty cool. So, do you all have questions about this so far? When is it due? We will be literally doing the presentations Tuesday, November 17th. So, what is that? 2.5 weeks.
I got it.
Yeah. Tuesday, November 17th, and it will be kind of during lab time.
Okay.
So it'll probably
First or
be,
second lap time.
I'll probably make it go back to like the old original lab time, whatever that was.
2 to 4.
2 p.m.
And everyone will be there?
Yeah.
We'll have to do it in here
Oh,
or some other room. How many of you could do 2 to 3 p.m. on a Tuesday? or I should say, how many people could not do 2 to 3 p.m. on a Tuesday?
You just have to miss practice with.
Yeah, I'm tired of losing practice. And him trying to tell me I gotta make it work.
What time does practice start? Or end?
4.
Yeah, we'll figure out, if there's an alternate time. We could do it during a lecture time if we needed to. Would that work? 10 people, 5 or 6 minutes apiece.
Could we just do where all of us except the people that can't do our presentations got lab day and then they do?
Maybe. I'll think
It.
about options for, it's just that whoever's not there missed the others. So I'll figure out a time what would be best. And bring this unknown reports sheet with you on Tuesday, and I'll go over that more at that time. But now that you've got your parasite, you can kind of start looking at where the basic info and kind of be keeping an eye out. Because once in a while it'll be in the news that somebody had this infection and died, or there was an outbreak of so-and-so in Missouri, or something like that. Okay, there's several more slides on vaccines, but I'm not really going to write much about them. I just mostly want to talk about them. So vaccines and the elimination of infectious disease by using vaccines has been one of the great human health improvements of the past 100 years. And it has changed global health so much for the better. But there was something that happened I guess it's been about 20 years ago now, that made people think differently about vaccines. So we went from having a new effective polio vaccine being headline news and great celebration. So this nurse is showing this guy who has polio, and he's in an iron lung. This is like an early external ventilator. So polio eventually paralyzes your lungs, and you can't breathe. So he has to be in this machine for the rest of his life. And she's showing him this good news that in the future, this doesn't have to happen to people if they get vaccinated. And that vaccine work was largely coming from a gentleman named Jonas Salk. And if there are saints in science, he would be one. So he worked really tirelessly to develop polio vaccine, and then he didn't patent it because he wanted it to be as cheap as possible and available as possible to everybody. He didn't patent it, and it's largely thanks to him that polio was mostly wiped out for most of the world. And we don't really have kids in the U.S. anymore that are getting polio, but there are older people that you sometimes meet that had it as a child and survived it, and they may not walk well, but they're still around because they survived it. But about 20 years ago, there was a big drop in vaccine compliance. This means how many people who are supposed to get certain vaccines actually do. That's what we mean by vaccine compliance. And that also is largely due, to one individual who also was a doctor. His name is Andrew Wakefield. And back in the late 90s, he published a study in a good journal. Like, if you said, oh, I want to use the Lancet as a source for my parasite presentation, I would be like, yes, that's a good journal. This study that he did was in a good journal, and it correlated having autism with getting MMR vaccine. So MMR is measles, mumps, rubella. Measles, mumps, rubella is what that stands for, and that's one of the standard childhood vaccine combos. So you get this when you're 18 months, and then you get the booster when you're 4, and then you kick nurses. No. But that day that Joseph kicked the nurses, he was getting the 4-year-old shots, and that's the booster day for this one, as well as some others. So Dr. Wakefield and some colleagues published a study that said that kids who get autism were more likely to have also gotten the MMR vaccine, and that was very scary. Very scary. And the Lancet is a British journal. So that was published in 1998, and this is vaccine compliance here. Notice that before 1998, 92% of British kids got MMR vaccine every year. And if we had looked back in time, this would have been a flat line. And starting in 1998, or a little bit before, that number really went down, and it went down all the way to 80%. Not 0, but 80%. So it used to be 92% of the kids got their vaccine for MMR, then it went down to 80. And that was basically because of that article. And that lasted for 6 years until it started climbing back up. Maybe that doesn't seem like a big drop, but in the meantime, here's vaccine compliance. That's in the yellow. So we see it goes from 92 to 80 at the lowest point. And the blue line here is how many people are getting measles. How many cases of measles in the UK? And it was very few. Look over here, like maybe 100 a year, until it reached eventually about 3,000 a year. Measles is not like SARS-CoV-2, where kids get it and they're like, oh, they got a sniffle, they're fine. A certain number of kids will die from measles that get it. So this is really bad. And it doesn't take much drop in vaccination to let a disease that was basically under control come back. Just that level of drop. So this amount of drop, just that little amount, caused the loss of what we call herd immunity. Caused the loss of herd immunity. And this word, or this phrase, herd immunity, has been in the news so much lately. But what it means is there's enough people, slow down, right, carefully. There are enough people immune so that a disease can't really spread well. The disease can't really spread. Herd immunity. There are enough people immune to the disease, either because they've had it and recovered, or they've had a vaccine that worked, so that the disease cannot circulate very well in populations because there aren't enough people left who can catch it. That's what herd immunity is. So these days, there's kind of a debate. Should we let people just try to develop herd immunity to SARS-CoV-2? Or should we try to take measures to like slow it down and prevent people from getting it until we can get a vaccine? King's student population by the end of the spring might be approaching herd immunity. This is not like on purpose. I don't think this is like a goal of King, but just with how many people have tested positive, and it's a few at a time, and it might go up and it might go down. But over time, King students by the end of spring might be approaching herd immunity. But waiting on herd immunity and just letting it rip through the earth is not, too many overall will die. Even if the fatality rate is 1%, letting herd immunity happen worldwide with SARS-CoV-2 would be staggering numbers of deaths. So having high vaccination rates maintains herd immunity. And another big question is, what level of people will have to get SARS-CoV-2 vaccine to have herd immunity? And it's apparently not 80%, they think. It's probably going to be about 60%. So that's like what I want to know. Well, I want to jump into the future and say, like, how many people actually are going to get SARS-CoV-2 vaccines? And is it going to allow herd immunity so that one day we won't have to wear masks? Wish I could see what would happen like a year from now. So measles coming back in England and the UK. We're all connected now as a global world. So in 2014, there were a lot of measles outbreaks at Disney World. And then a few up in the Bay Area as well. And I know you're from Pacific Northwest, which is a low vaccine compliance area. I think there's been measles there as well. Do you know? I didn't pay attention to things like this when I was young. But measles is back now in the US because of people being afraid to vaccinate and worrying about vaccines causing autism. The paper that Dr. Wakefield authored was retracted. So that means that the journal takes it back. It's not true. But it was, the retraction was maybe like 6 months after the paper, but it was already out there. Like, vaccines cause autism. Don't let your child be vaccinated. He also lost his medical license. He's no longer a doctor. And it came out that he was starting a company to help provide autism treatments. So he had a financial interest in letting people know that autism was a common problem, or there was a financial conflict in what he was doing with this paper. It wasn't true. Since then, there have been hundreds of studies, good studies, big studies, careful studies. And those studies taken together have not found a link between vaccines and autism. There is no scientific link between vaccines and autism. There's just not. What's unfortunate about this is the age that kids get MMR vaccines. You get it when you're 18 months, the first time you get the shot. Autism spectrum disorders show up around 2 years old. You can't tell that the child usually is going to have autism spectrum disorder until after they're 2, which happens to be usually right after they got that shot. So it makes it seem like they were fine until they had the shot. That can kind of be a true statement, but that doesn't mean that the shot gave them autism. So this was one of the world's most unfortunate scientific studies ever, because it's really led to a lot of deaths of kids around the world that didn't get vaccinated and they got measles and suffered from it, and most of them recovered, but not all. The rest of these slides, we don't need to go over. Wait, what is this one? Okay, we do need to go over this one, or just talk through it. There are a certain number of kids and grown-ups who get vaccines and they have a real adverse event. That is a true fact. They happen to a few people every year. Vaccines don't cause autism. But this fact, relating to this fact, opens up a lot of different questions. So, knowing that there will be a few people that have vaccine injuries, then we have to make individual choices. Should I get this vaccine? Should I get it for my child? Should anyone ever be able to say, you must have this vaccine? Does that happen?
Kind of with like tetanitis or whatever that is, like tetanus.
Tetanus?
Yeah, it's like, I mean, it's part of like my normal shots.
Yeah, so like when I'm saying
I had
normal,
to get it. It wasn't really
normal
choice.
shots, there are people at King that have gotten exceptions, like I have a religious exemption to vaccines. And we have King students that haven't had their normal vaccines.
Like
Because it's really hard to say, we're gonna make you get this vaccine. When you work as nurses, someone will make you get
My
vaccines.
brother is a pharmacist and he has to get them, and he has to get, what is it, like a TB test every so often.
Mm-hmm. Yeah. So when you work in healthcare, then you can be forced basically to get vaccines to keep your job. But like King right now does not force vaccines.
I think they will in the future.
Mm-mm.
No.
I'm speaking as my own self and not as a King spokesperson, but I don't think that it's going to be strongly encouraged. They might make the faculty get vaccines. But now everybody's kind of, like right now we're in a moment where everybody's like, yeah, we need a vaccine. Hurry up. But it's strange over the years to see like people not enthusiastic about vaccines, people really waiting on a vaccine. And I was reading an article the other day just about, it was a hypothetical, if Mr. Biden were to become the president, would he make a nationwide mask mandate? Because technically you could, and it was saying that he probably would not because that's just so controversial. But it was talking about what are ways that without mandating, you could get more people to wear masks overall. It was pretty interesting. These are fun times to be learning about immunology because you already know a lot of it now before I even teach it to you just from life. Say that. So let's go on to our next slide set, and this slide set is the last one for this unit. Last one for this unit, and we'll be talking about this today and then Monday. And Wednesday is going to be a review day. You don't have it?
No, I thought, because I figured we had like half of this to go over.
I have an extra one. I
You
don't
do?
know why.
You have an extra
I
one?
don't know why, but.
Providential. I feel like that's something that only old people say. It's providential.
What does that mean?
It kind of means like God's grace. I've officially become old.
So, thank you.
So this last unit is talking about the disorders of immunity, which is something's going wrong with your immune system and it's not working the way that it should. So having immune disorders assumes that something's going wrong with your immune system. And there are two major ways that your immune system can have problems. It can either overreact to things that aren't dangerous in the first place. Or it can underreact and fail to stop actual dangers. So we can have a dangerous overreaction. Your immune system is freaking out on some kind of antigen that shouldn't really be dangerous. Or your immune system is underperforming and not actually protecting you from the real dangers that it should. Either one of these causes problems. And today we're going to start with the overreaction. So this is a very good review figure once we're all done with talking about the different types. And we can divide immune disorders into two big categories, which are hypersensitivities. These are the overreactions. Our body is overreacting to something and causing a hypersensitivity. Or we have hyposensitivity, which means we're undersensitive. Those are the groups of problems where we're not protecting enough. There's 4 kinds of hypersensitivities called types 1 through 4. There are 2 divisions of hyposensitivities, and we can also call those immunodeficiencies. The immunodeficiencies I'll talk about Monday. We'll start talking about hypersensitivities today. And just as a preview, before I go through the individual types, allergies fall into a type 1 hypersensitivity. That's where allergies come into play. And then these others are less common in people. We'll talk about how do they happen and what problems do they cause. This is more useful at the end after I've talked about the individual types. But these are going with these 4 categories here. We'll come back to that table later. So the first set that we're going to talk about is type 1 hypersensitivities, which we mostly know as allergies. When people talk about, I'm allergic to such and such, they actually have a type 1 hypersensitivity to a particular antigen. So type 1 is characterized by an immediate response It's an immediate response to a particular antigen. And it's not just any antigen, but it's a particular antigen that shouldn't be dangerous. It's like that shape itself is not even a problem, but our body thinks that it is. And we think that we should be fighting against it. What's the weirdest thing that you all are allergic to?
Penicillin.
Penicillin,
Family
the family,
tree, like amoxicillin, and all
Mhm.
that stuff. Trees.
pine, pineapple? No? Good for you.
There's this one person last year who was allergic to all of like, Alyssa, she was allergic to all, like, mature, like, all like fruits and stuff that came from a plant.
All fruits?
And like, anything that came from a plant.
Wow.
It was like
That's
the type
rough.
of seed that like, yeah. It was
She's
weird.
still here.
No, she moved.
I didn't see her around lately. Han is allergic to brown paint and most kinds of antiperspirant. He can only use deodorant, like just regular deodorant. And he gets this weird rash from it. That's actually a type 4, but I'll come back to that later. If you have the immediate response to the allergen, like right away, within 2 minutes, it's type 1. And there can be so many different things like penicillin class drugs or bee venom, pollen, peanuts. Noah is allergic to peanuts. Latex, all of those could be allergens. So we call the antigen that shouldn't be dangerous, that's what actually an allergen is. We classify it as allergen, and that particular shape can initiate a type 1 hypersensitivity or an allergic response. But this type is always going to happen immediately. And that's different from another type that we'll see coming up later. So when we become allergic to something, there always has to be a first exposure. I mean, of course there is. There's always a first exposure, and the first time that you come into contact with that antigen, it's not an allergen yet. So the first time that you're exposed, the antigen doesn't cause an immediate response. It doesn't cause an immediate response. But what is going to happen is your body is going to learn and decide during that immediate first response that red ball right here, which is the antigen, is some foreign danger. So here comes red ball, and it is activating T cells and B cells. It's the perfect enemy of some T cells and B cells, and they get activated by this allergen, and the B cells will produce plasma cells, and the plasma cells will produce antibodies, and they specifically are going to be IgE. They're going to be the E class of antibodies. And those E class of antibodies become receptors. They become receptors on these white blood cells called mast cells. So the plasma cells make them, they then go and become specific IgE receptors. This is IgE on mast cells. And then the mast cells go and wait to re-encounter. What I want to write is they wait to encounter the allergen. So we encounter some antigen that's not dangerous, actually. B and T cells learn that it's dangerous and we should watch for it in the future. They produce plasma cells that make antibodies. The antibodies become receptors on the mast cells, and the mast cells go and wait underneath our body portals, let's say, until they see it again. So the second time that we see, or the subsequent, pretend I circled subsequent. The subsequent exposures, the mast cells now are there and waiting, and they will bind to the antigen, and they produce these inflammatory chemicals. Which are the purple dots now. They're producing inflammatory chemicals. Inflammatory chemicals is what that says, that go into our bloodstream. And these are going to cause inflammation, it depends on where this antigen came to us, but they're going to cause inflammation.
How come our body even like generates the B cells that are made for that specific antigen if it's not originally dangerous to us?
The reason that we make T and B cells for non-dangerous antigens is that our process of making T and B cells is to put together millions of kinds of random binding receptors.
So then how come not everyone is allergic to the same stuff?
Yeah.
We all have the same B and T cells too.
It's thought that the reason that some people are not allergic to the non-dangerous stuff is that when they were young, we're supposed to get rid of T and B cells that react to non-dangerous stuff.
Okay.
But we don't totally know how that works yet. But there's something, when we're less than 10 years old, it's really less than 7 years old, our immune system is supposed to learn in our world what's me and what's not me, and also what is a normal part of my world that I should just ignore, like pine pollen. Are you from Georgia? No. You're from
Jonesboro.
Yeah. Pine pollen is part of our world, and we really don't need to be fighting it so hard. I'm allergic to some other kind of pollen. I really don't need to be fighting it so hard.
Mine are bad. Like I had to have allergy shots when I was younger, and I had an allergic reaction to those too.
No,
I
no.
went to, my mom used to work for an allergist in Greenville,
Mhm.
and I got allergy shots for free there because she worked for him, and I had a bad allergic reaction to those too. So,
Oh, I'm sorry.
Like all times.
only really in the spring. I really only have it bad in the spring.
Do you?
No. Mine just don't
We
take
used to
medicine
have
and
one
I'm
for
good.
Noah, and they kept expiring,
Yeah.
and they were so expensive. That was before I worked full time. It's like, we can't keep buying these and having them expire. And then he eventually learned how to smell peanut and everything and not eat it. And his isn't the life-threatening kind.
That's it.
Yeah, I'm glad.
I mean, mine's kind of easy. I just don't get penicillin shot.
Well, yeah,
Or I mean, I just have to let my doctors know because that's kind of like an antibacterial type thing.
yeah.
It's pretty common.
That's kind of sad. You can have a good peanut butter and jelly sandwich.
We can't even have pets. That's saddening. Because three people in our house are allergic to various kind of pets, and it eliminates those cats and dogs.
What about like a
I
hamster?
go on identic dogs.
Hamsters.
Yeah, I know.
Like
But also, we
rabbit?
don't want to have pets. It's kind of like,
Oh, okay, that makes sense.
especially mine, like pets in the house are just not, I don't know about Filipino society.
No, my parents were so against it, they hated my dog. And I was like, this is wrong.
Yeah, my sister-in-law had birds for a long time, even that was like, birds. So anyway, these inflammatory chemicals spread around the body, and in certain places, they will do certain irritating things to us that are trying to help. So certain ones in the lungs can dilate blood vessels and constrict bronchioles at the same time. So you have kind of like fluid leaking into the lungs, and you have your airway shutting down. Asthma, like setting off asthma, That's kind of how that relates to allergies. So if people have allergies that trigger asthma, that's why, because the certain chemicals that are being produced are causing blood vessel changes and airway changes in their
What
lungs.
if you just have like asthma in general?
Asthma in general
Because like,
is
I had like
triggered by,
asthma growing up as a kid,
and did you grow out of it?
sometimes, yeah,
Sometimes, yeah. It is triggered by something.
something. You know,
Yeah.
like for me, like if I'm in a stuffy pool and I'm practicing really hard,
Mhm.
then I won't
Some
be able
people,
to breathe.
cold air triggers it.
Yeah,
Yeah. But it's the same stuff happens. It just can triggered
just
by
our body
something that's not
recognizes
an
that we're not in
allergy.
a healthy state and tries to help with it.
Yeah.
Okay.
And basically, like having blood vessel dilation, that is what happens during inflammation that we learned about. It's just happening here. And it also is constricting muscles in the airways, which is not helpful. This and this are the same process, but this is showing it bigger. So airways, muscles constrict, and you also get mucus buildup, which is trying to help, like, oh, let me help you get rid of your problem, make more mucus, but the combo of that, you've got too small of a airway to breathe through. And then you need inhaler, which reverses those effects. Some of the inflammatory mediators can sometimes cause headaches. Some of them will cause skin inflammation, where you dilate blood vessels, you get swelling. In this case, the allergen has gone through the skin to produce this effect. If this happens in your gut and you get gut inflammation, you'll have diarrhea and vomiting, and your body is like, let me help you get rid of that. Let me help you get that out of your body. That's diarrhea and vomiting. And let me help you cry that away. Let me help you snot that away. Same. Your body's trying to help you, but it becomes more problem than help. Yeah.
I'll actually,
Okay.
kind of a weird question.
I don't mind. But you could ask it now or later.
Will your body allow you to like vomit and like, you know, shoot it out the other way?
That's
at the
never
same
happened to
time?
you? You're lucky.
Is it supposed to?
When I was in college, I got the worst food poisoning at O'Charlie's. And I lived in the dorm. I went back to the dorm, and that happened to me. Like basically simultaneous, or enough so that you cannot like get off the toilet and turn around to throw up in
Oh
it.
my God.
So I know this is gross, you all, but it's Friday. So yes, it could happen at the same time. And so I decided, like, I just better stay sitting down and just deal with this later. And those of you that live in Liston or Parks and you have the group bathrooms, we had bathrooms like that. And I remember, like, I vomited and it splashed up on the stall.
Oh my God.
That's
And
janitor.
they didn't clean that, like, for the whole year, that part of it. It's just, my dorm has now been torn down because it was so decrepit. But yeah, it can happen at the same time. And if you get really violent food poisoning, it can, and it's just terrible.
I'm so sorry.
I hope it never happens to you.
Me too.
But it totally can happen.
Okay.
And I never go to O'Charlie's anymore. But yeah, it can happen at the same time. One thing that I'm going to show you like examples of how allergies look like, but the point of this is not for you to be able to look at somebody's rash and say, type 1. This is just for
Let's
example.
be excellent.
Is eczema a type 1?
Is that more just like?
Eczema is more of
condition?
like a type 4. But this definitely looks like eczema.
Yeah.
And that's why I'm not here to say like, you see this, it's this. That's for dermatologists. But if the response happens quickly, if you get a quick, like less than 10 minutes until the response starts happening, that's type 1. This particular thing is an antibiotic. This is antibiotic. or red dye or something that the person ate. And it quickly gets into their blood and they have the whole body rash. If you felt this, it would be smooth. These are the allergen, it's coming from outside the body. So this one's probably, they're putting the wrong lotion. Noah had that. And there was only one lotion that we could use. And he can't wear any of the chemical sunscreens or that will start on him. Fortunately, he's pre-tan. He doesn't need sunscreen. He's like, just get dark. It'll be fine.
Skin cancer.
He's not like me.
Um,
Yeah. But then my in-laws are like, they're so dark. We won't go there. Anyway, if it happens quickly, less than 10 minutes, that's a type 1 true allergy response. So when you're doing people's charting and you ask them, when did this start? Like, that's really important. When did this start? Like if you become a derm nurse. And then you would ask them, have you used any new products? Have you taken any new medicine? All of that can help figure out what is happening.
Is this also for like, you know, like UTIs as well? So like if like you're using like the wrong soap or whatever, or like.
Does the wrong soap cause UTIs? It's not truly a UTI, but it can be inflammation like this.
Okay.
Yeah. It wouldn't cause an infection, but the soap, if you're truly allergic to it, can cause a local allergic response where you're using it.
I've had that happen. I used a Bath and Body Works body wash, and all the scents and stuff made me have hives.
Mm-hmm. You got hives?
I'm so.
Is it all Bath and Body Works or just the one?
Don't really know. I didn't try anymore.
You didn't try anymore. Of course you didn't try anymore. That's smart. What did you say?
Mine's all of Bath and Body Works. I think
All of Bath and Body Works.
fragrance is in it. It's like so strong.
Yeah, I can only use the perfume. That's it.
Only the perfume.
Yeah.
That's interesting.
what's that? That's body wash.
It smells good, but I'm not gonna be itchy.
They do, some of them do smell good. So when people go for allergy testing, what's literally happening is you're putting, putting small amounts of antigen under their skin and see which ones are they responding to within a short amount of time. Do you remember how long the time?
15 minutes.
Okay.
No, it was 30 minutes, but
30?
they had to take it off in 15 minutes for me because they had like the pond and the
Mm-hmm.
swollen up here. My shoulder was swollen like the size of a baseball in 15 minutes, so they had to take everything off.
But how do they take it off? It's already in
They
there.
just like they took like a wet rag and wiped it.
Oh,
down.
wiped it off?
Yeah.
Yeah. Did they give you Benadryl right after? Yeah.
One of
Yeah,
the-
once you put it in, you can't get it back out.
The allergen my mom worked for was
Mhm.
like one of the pioneers in creating this test. So
Yeah.
He's from Poland, so he kind of, I don't know, it helped, so.
Yeah. So basically, the bigger the welt, the more allergic response you have. And see, there's one right there that they didn't respond to at all. So to kind of recap what's going on in an allergic response. You have the allergen the first time. This would be the first exposure. Well, no. You have the allergen. It induces the plasma cell. Plasma cell makes antibodies, which are IgE. Remember, these are IgE style, and they become a receptor on a mast cell. And then when the mast cell again detects this same allergen, then it causes the problems. It causes the problems. And remember that really all of these problems are basically coming from inflammatory chemicals that are doing inflammation in specific places. So if you eat the allergen, the inflammation is going to be in your gut. If the allergen goes through your skin, the problem is going to be in your skin. If you breathe it in, you're gonna have an asthma type response. And
Is there any
if it
way
gets
to,
in your
like,
eye and your nose, you might have this.
no, but is there any way to like lessen like an allergic response? Like if you like repeatedly purposely expose yourself to
Yeah.
chemical, would your body eventually get acclimated to that?
Yes. So on this slide, down here is talking about all the different ways that we have to treat allergic reactions, like where are they stopping the problem? Like in the one that you just mentioned is immunotherapy, and I'm gonna write that one over here. So if people do immunotherapy, well, I'm gonna call it immunotherapy. If people are getting allergy shots, that's what you're talking about, basically. You give somebody tiny amount of allergen repeatedly over time to induce tolerance. And this is one of those things that we don't know why this works, but people have figured out that you can do this. You can give somebody repeatedly over time a little bit of allergen, barely any, and then over the next time, like slightly more, and let your body become accustomed to knowing that this is not a danger.
And so would that process be like, you like wouldn't use like an EpiPen to try and like shut that down?
Yeah,
Or you just
so
let the
if it
body deal
works,
with it 100%?
you're not allergic anymore. So kids that take allergy shots so that they can have pets, that's the style. This didn't work for you, I guess.
Well, it worked for a little while,
For a little
but
while.
as, I guess it's like in a series of weeks. So like they increased, like you said, but I guess it was like third week or something, it was too much. And
Too much
it's
too
a big
soon.
time allergic reaction.
Yeah, if you had it when you were a kid, like it may have been semi-experimental. Especially like the pioneers in the field will often try stuff like that. This kind of thing, they've done very well with peanut for kids who might die if they eat peanut.
Oh.
Kids like Noah that are allergic to peanut but not gonna die, they wouldn't go through this, but
Yeah.
that's where the best research is done recently, because that's really dangerous for them, and they want to get them to the point where they at least won't die if they eat a peanut.
Can you do this for like people who are lactose intolerant?
That lactose intolerant is not a real allergy, it's something else.
Oh, okay.
I wouldn't,
You just don't make the enzyme. And then the bacteria in your gut are using the lactose, and they're making acid and gas
Mm-hmm.
as waste, and then that causes you the problem.
Oh,
is that then the same for like diabetes? Because it's like type 2 from the next slide, so like type 2 diabetes. That's
Yeah,
something you're
type
born with.
2, type 2 diabetes is our immune system has attacked our own self. That's more like an autoimmune development, and we'll get to that later. But this is something that is kind of new and experimental to help allergies. Or you can tell the person, just don't eat that, don't have a pet.
So
We can't like avoid pollen. I mean, there are some ways, but not really. You can take steroid drugs. I'm not gonna list out what their names are. This one is cheap to do steroid treatment, like hydrocortisone or cortisone injections. That would be a steroid. This type is expensive, using, I'm gonna draw a dollar sign. Monoclonal antibodies. This kind of drug, cromolyn, can help, but that's not over the counter. These are cheap and very used. So antihistamines, Benadryl would be this. Benadryl, pretend I wrote Benadryl. I could write it over here and then draw an arrow. Benadryl, stuff like Claritin, what's the one with Z? Yeah,
Zoltol.
Zyrtec, those are this type, and so they're kind of acting at a late point. It would be better to have drugs that act back here, and steroids do, but they mess up a lot of other body systems. And
Yeah, because then
Can
wouldn't
make
that
you-
mess up when you actually need the IgE to be
Yeah.
made?
steroids would reduce all of your immune response, actually, which
So
is not the
then you
best.
become more immunodeficient then.
Slightly, yeah. Slightly so.
Okay.
So actually, I wanted to get through just allergies today because the other 3 classes are not as common. But Monday, bring these same slides, and we'll talk about the other hypersensitivities, starting with type 2, and then the hyposensitivities.